Good afternoon now. Welcome to this session. I hope you're all enjoying SQLBits. My name's Alex Whittles. All my contact details are on the screen. Any questions you have, I'm happy to take questions as we go through the session for both virtual people and everyone in the room. If you're virtual, type it on the Canopy app and I should come up on my screen if the tech works. If there's anything particularly long we need to answer, I can take the questions afterwards or come over to the Power BI Sentinel stand or the information desk where I'll be camped out after the rest of the day. Right, so what are we talking about? Well, first of all, a bit about me. I'm on the SQLBits Organising Committee, so on behalf of the committee, a warm welcome to you all. Thank you for being here this week. Wouldn't be an event without you being here. I also run Purple Frog, a Microsoft data analytics consultancy, data warehousing, data lakes, ETL, Synapse, machine learning, Power BI, etc. I've got a full team who look after that. I'm a data platform MVP, and I also run Power BI Sentinel. You may have seen some logos around. We're a sponsor as well. Covering all aspects of data governance, auditing, disaster recovery, usage monitoring, everything you need to better manage your Power BI environment. This session is not about that tool. If you want to know more about that, then come and see us on the Sentinel stand, and we'll be happy to talk to you about it. This session is about complex and hybrid models in Power BI, how to take Power BI to another level of really allowing you to manage it better by better using different ways of getting data into it. So we're going to be looking at ways you can get data into a Power BI dataset. We are going to be going back to square one, something that all of you will know. So don't worry, it's going to start basic and then layer on top of that. Then we'll be looking at combining different types of datasets into more composite hybrid models, layering datasets on top of each other to reuse logic, and use that to improve our data management and shrink and decrease the duplication of data in our environment, and make data available faster and easier for different data types. Right, so let's go right back to square one. How do we get data into Power BI? The default option is import mode. You suck the data out of whatever source system is coming from. Excel, text file, SQL Server, Oracle, SAP HANA, doesn't matter, just import it in, clones the data into your Power BI dataset. We'll talk about these in a bit more detail in a minute. Direct query mode, where the data stays in the source system. Power BI just acts as a pass-through. It deals with the visuals and then turns the visual into essentially a SQL query, and it goes off and runs it in your source system. So it's essentially a live mode. The traditional composite model is where you have a little bit of both. You have some data in your source in direct query mode and some data that comes in import mode. Then we have live connection, where either a cube or a Power BI dataset is essentially one data entity, and you can have multiple reports all consuming the same dataset. Centralization and standardization of your datasets in either a cube or a dataset. Now we have what is probably the best known acronym Microsoft has ever come up with, DQOA-SAPBIDS, which is beaten SQL Server Analysis Services as a Service, SSA-SAAS, which I also loved. This is direct query over Azure Analysis Services and Power BI datasets, or as everyone likes to call it, the new composite models, where you can actually take an existing dataset and cube now, and layer on more data to enhance it further and build upon an existing data set to do more with it. And we'll be talking about how to do that later on. So let's look at a few of the pros and cons of doing these. Let's go back to the first one. Hybrid tables. These are a great thing where you can actually combine import and direct query in a single table to get a combination of import but live data today. So we'll talk about these in a bit more detail. So import mode. This is still the default best option for the majority of your datasets if you're in a simple world. For single-purpose reports, go down this route. It is simple, it is fast, all the data is compressed in the Vertipack compression engine, about 10 to 1, so it shrinks down massively. All of your reporting, the actual CPU to drive your reports is purely Power BI. None of it's hitting your source systems. The only time your source systems get hit is when you refresh the dataset once a day, once an hour, etc. So it detaches that compute workload away from your source. There's also no limitations. You have the full functionality of all Power Query and DAX. There's no limitations to what you can do in these reports. But you have data latency. Let's say you refresh the data once a day. you're not going to get today's data. Even if you refresh once an hour, you're not going to get live information. Now, in reality, how many reports need live information? Not many. But it's an issue with this. Sometimes processing, we've got some customers' data sets that take hours and hours and hours to refresh. You can't refresh them during the day. And overnight, they have a massive hit on the source systems. And there's also a limitation as to how big they can be. You're not going to put a petabyte of data in here. You're talking gigabytes, not terabytes. So let's look at direct query. Well, we can get over all of these issues. We can have zero latency, as big as you want, if we keep the data in the source system and go through direct query. If your data lake can handle a petabyte of data, well, you can expose it in Power BI with a petabyte of data. Great. And it sounds like the perfect solution to all problems until you use it. And it's rubbish, because it's utterly, horribly, painfully slow. In most cases, unless you have a super fast source system. You certainly don't want to use this as a default for any of your reports, unless there is a specific special case where you need it. I've got a customer that wanted a real-time dashboard displaying in a manufacturing facility, about 5 different dashboards, where they need real-time manufacturing information on the throughput of different machines and staff in that building. This hits their Dynamics AX database in real-time, direct query, all through the day. That database server is at 100% CPU 24/7, just coping with this DQ workload. So obviously that has a massive impact on that Dynamics database. So we've had to create an always-on replica. You double your licensing costs to make this happen. There's a huge cost in doing this, so be very, very, very careful. You also have limited Power Query and DAX. Now, I'm not going to go into the nuances of query folding, but anyone that understands query folding, you can only use Power Query that can be folded. So basically, Power Query that turns it into a SQL statement and fires it down to the database, rather than using Power Query functionality inside Power Query. As soon as you lose query folding, you can't do direct query. You also have limited DAX. You can't do things like time intelligence functionality, because the underlying database doesn't understand time intelligence. That's a Power BI thing. There's also a 1 million row limit, but that's not as bad as it sounds. It's 1 million rows of data being returned to Power BI, not 1 million rows of source data. So if you aggregate it, it's fine. And that's per visual. Anyone that wants more than 1 million rows in one visual is doing Power BI wrong. So it's not actually a big problem. So let's now look at, well, we want the benefits of direct query with zero latency. We don't want to have to hit a petabyte of data in our source system every time we want to refresh this week's sales. So we can get composite models where we kind of pull in some data in import mode and some data in direct query. And we can decide what's going to be what. So we can target the majority of our functionality to be fast in import, but we can say for certain niche queries, they're going to go off and do direct query. What does this look like? Well, let's take a simple website viewing database. How many times has our website been hit? So we've got three dimensions in the simplified model. We've got our date, our time, and our web page. Now, this data, in my example, is only a couple of million records, but in reality, that could be billions and billions of rows. And we need it to be direct query because we need low latency. We need it to be to have today's data in it, for example. So what we don't want to do is every single report have to hit that fact table and go direct query to the source to scan those billions rows of data. So before composite models was a thing in Power BI, what you could do is create another table next to it that was imported, but aggregated. So create a view in the database, select star from the fact table, group by date key and web page key, sum the measures and bring it in. And that's going to be a tiny fraction of the size of the number of rows because you're pre-aggregating it. So you could have that table in import mode, your original table in direct query, and then you could write some DAX that says, well, and actually I should say, well, if the majority of our reports and visuals are only using date and web page, then that's great because we don't need to include time in that aggregation. We can make it really, really small. So you can see here the date and page dimensions hit the aggregation table, but the time dimension only hits direct query. So as soon as you want to filter by time, you're going to have to go to the direct query. And you could then write some DAX that says, for this expression, if is filtered dim time, then go to the direct query table, otherwise use the aggregated table. Well, now you don't have to do that manually because composite models do it for you. You define that in Power BI Desktop, and it will automatically switch between these two tables for you, massively simplifying your DAX. What does that look like? Let's go to demo time. Let's get that switched. There we go. So this is our, don't worry about the details of the text, but fundamentally the same three dimensions. Web page on the top left, date on the top right, and time on the bottom. What I'm going to do, and you can see if we hover over these, let's go to that. You can see these are in import mode. So I'm going to bring in some data from our Azure SQLDB. Let's pray to the Wi-Fi connection and demo gods. And the typing gods. I'm going to bring in my my fact table. I'm not going to bother transforming it. I'm going to bring in the whole thing. And I'm going to bring that in direct query. And helpfully, it always puts it off the screen. Every time. Right, I'm just going to create my relationships. And time key goes to time key. And my web page key goes to my web page. So now I'm just going to add a couple of, let's collapse that and bring it down, a couple of measures to this table. Don't like writing DAX live, so I'm going to cheat. So I'm just going to add a total duration, how long does the web page take to load, and a number of hits. We've got one hit per table row, so just a count of that table to get the number of times we've viewed a web page, and then an average duration. How long did each web page take to load? Using our favorite average function. So we can now build a visual from this. Let's bring on the hits, and we sit there and we wait. Okay, that wasn't too bad. What I should have done was turned on the performance analyzer, and that's a little bit too big. Let's drag on a filter of, I don't know, let's go for calendar year. Turn that into a slicer. In fact, no, I'm going to get rid of that. I'm going to put calendar year on the x-axis. I should have started recording. And then maybe day of week as a slicer. But you can see there, straight away, that took over 10 seconds to load. Now that's only with 1 million rows of data. And every time we interact with this, you can see it's just spinning, spinning, spinning. And every time you do anything, it's going to be at least 10 seconds to refresh the page. And that's not ideal. So what I've done is I've created a view in the database, which is simply group it by date and web page. Those are our grouping keys. And I've summed the load duration, and I've counted the rows and that column. So I can then go back to my data model and bring in another table. So this is my view. And I'm going to import that data. Now you can see the color of that table is blue, the color of that table is white. That indicates there's a difference between those tables. In this case, blue is direct query and white is import. So you can straight away use that to get a visual reference as to the difference between different tables in your model. We call them different islands of data. So again, helpfully off the screen, let's bring it on. So we can see, well, this one's white, so we can see that's in import mode, and that one's blue, so it's in direct query. So how do we tell Power BI that these are actually the same table, just different versions of the data? Well, we click on the little ellipsis there, manage aggregations. and we can tell it the relationship between these tables. So what do we have to put in this? Well, if we go back to our view, the first thing is we're grouping by date key and web page key. So let's tell it we're doing that. Date key is a grouping of fact web hits, and it's a grouping by the date key column. Web page key is a grouping of the same table, and this is by the web page key. What else have we got? We're summing load duration and calling it load duration ag. So load duration ag is just a sum of fact web hits and load duration. This is why I like doing it in a view rather than in Power Query, because it makes it much easier to translate from the view to this configuration. Row count is simply a count of the table rows, and web hit count, let's say that's a count of the primary key of the table, web hit key. Now note at the top, you've got an aggregation table and a precedence. You can create multiple aggregation tables based on different aggregations of fields. So you haven't got to have one that has every field. You can have different combinations if you want to. And you can set the priority of them using that. So now we do that, straight away, this is hidden, that table. So this is now a hidden table behind the scenes that you cannot see in your data model here. This is the table that users interact with, and Power BI decides which one it's going to use. So now, if I interact with this, you can see it instant. So clearly it's hitting the aggregated tables. You can see from the performance here, it's now taking a couple hundred milliseconds rather than the 13 seconds it was before. Instant performance gain. So what happens if we bring a time attribute on here? Let's go time hour of day and add that on as a slicer. If I interact with this, what's going to happen? It's going to sit there spinning. Because now there is a filter on the time dimension. The aggregation table is no longer available, so it has to hit the direct query table, and it's going to take 13 seconds. And we can see down here, about 13 seconds. Does that make sense so far? All good. Any questions? Excellent. Right. So, as well as having our the number of web hits on there, I want to bring in average duration. Let's clear the filter on time. So we're now nice and fast again. And I bring in the average duration. In fact, let's turn this into a line chart as well and put average duration on the line axis. What's happening? It's spinning. So that's clearly hitting the direct query again. But why? Because all it's doing is taking the total duration and dividing it by the number of rows. Both of those are in the aggregated table. So what's the problem? Well, it's quite difficult to find out why that's not hitting the aggregations. A great way of doing it, though, is if you go to external tools, use DAX Studio. Anyone that wants to know more about external tools, the Tabular Editor team are over here on a stand. Really, really useful tool. Now, we're not actually going to use DAX Studio, apart from, down the bottom, it tells us the server and port number the Power BI is running as. When you run Power BI Desktop, all it does is it spins up an in-memory version of Analysis Services Cubes, Tabular. So I'm going to run good old Profiler. Profiler will never die, staying around forever. And we're going to connect to Analysis Services, and I'm going to paste in that server and port. And this is going to give me a profile trace on this internal Power BI server. I just need to deselect all of the fluff that it needs to get rid of. Why there isn't a deselect all button, I have no idea. And click Show All Events. And under the query processing, there is an aggregate table rewrite query event. Turn that on. And now, if we change a filter, let it refresh. There it goes. Now I'm going to go back to Profiler, and it gives me this aggregate table rewrite query, and helpfully it hasn't given me the column of data that I actually need. Let's try again. For some reason it's lost all the columns. There we go. What I actually want is the I don't know which column it is. Let's just do them all. Which one is it? Text data, I think. Let's try that. There we go. So what this is going to show us is the attempt at the request. And it failed the aggregate table match. Why did it do that? Because it was missing an aggregation on the load duration column. So load duration column, what was it asking for? The actual request to be able to hit the aggregation was a sum of load duration. We know we've got that. It was asking for the count of load duration. Well, do we have that? Let's come back to that. We know we've got count rows, and we know we've got our day key in there as well. So let's have a look at this count of load duration. If we go back to our aggregations, we can see that actually we don't have, the load duration only has a sum. The count was of the primary key of the table. And there is a fundamental difference between the two, because the DAX average function accounts for nulls, and it does not include nulls in the calculation. So if we're counting the primary key, that's never got nulls in it. It cannot use that to do an average of the load duration column, because that may have nulls. But if we change this configuration and say this is actually a count of load duration instead, and now we go back to our page, it's now nice and fast, and that's now clearly hitting the aggregations. And we can see that back from our profile trace when it now says our match has been found. So it's just a useful little trick to debug these aggregations, and when you start getting lots of complex aggregations, it can get quite complex. I've shown you doing it manually. There is now an option to automatically create aggregations. You can tell Power BI to monitor the usage of reports, of direct query reports, and allow it to automatically create aggregations for you. Who thinks that's a good idea? Has anyone used automatic as SQL tuning? Don't do it. I want to be in control of the performance of my report. I don't want to give a slow direct query report and let Power BI start to try and optimize it. I want to be in control. Personally, I don't think that's a good idea, but I'll leave it up to you to decide. Right, so let's go back to our slides. So we've done that one. Right, so now we've got our wonderful composite table. We can use this to create direct query over complex large data sets, but actually optimize the common use cases with the common dimensions. But we've gone to the trouble of building this complex model. But then someone else in the finance department or the sales department want to create a new report using the same data. What we don't want to do is have to train those self-service users in how to do this. We need to manage this carefully. And that's where live connection comes in, where we want to create and deploy a data set and encourage people to reuse it for multiple reports. Remove the duplication, remove the complexity of the creation of the DAX and the models. So what we can do then is we can say, right, let's take our model. I'm going to save it and publish it to powerbi.com. And I'm going to put it in the SQLBits 2023 workspace. There it goes. So now it's up in the cloud. So now I can give people permissions to the workspace. And anyone else can come along and say, right, I like the data that's in there, but I don't like the report you've created. I want to create a new report that does something different. They can then just use get data and choose Power BI datasets. With Power BI datasets, it shows them all the datasets they've got access to in powerbi.com. Here we've got our dataset we've just deployed. Connect to it, and we've now got a live connection to that same model. But we don't have any of the complexity of having to worry about building that composite model. I can just come straight in and say, right, let's bring on my hits, recreate the visual, average durations, that, and dim date our calendar year. And you can see the performance is exactly the same. let's add on our English day, put that as a slicer, and then do the same with time. So in this case, we built the same report, but you can build whatever report you want. But you haven't got to worry about rebuilding the data set. And the performance is still going to be nice and fast. It's still the import mode. Let's filter the time, and we get the eternal spinner for 13 seconds. So it makes it very easy to allow users to create their own visuals and not have to worry about the complexity of DAX or the dataset. The problem, though, is this, that they start building a report and the performance is great until they bring on another filter, time in this case, and suddenly it slows down. There's nothing in this model that tells them why time is so slow. So education is very important when you get users using these data sets. Tell them which dimensions are good and which dimensions are bad. In the original model, in the composite model, you could come into the data model and you could see that all the different tables were different colors. Let's relay this out a second. Here, they're all blue. So it doesn't actually help understand the difference between the different tables. Let's bring that back in. Where's that one gone? There it is. If we hover over these, everything is shown as SQL Server Analysis Services Database. Question on screen, is there a significant benefit to live connection over shared datasets? Shared datasets. Ooh. Live connection, you control the data. Good question, by the way. Live connection, you control the dataset. People can't access that dataset. They can just build a report off it. If you share a dataset, then, and I presume this means sharing it with external people, which is a new facility, then that's going outside your company. Yeah, I wouldn't use shared datasets. If you've got the ability to build a report on a dataset, that's all you need. Just create a new visual, new report on top of the dataset, and that's all you need to do. That's definitely the way to go about it. But here it shows you've got SQL Server Analysis Services. This shows Analysis Services is Power BI datasets. It's the same thing. Just the server name is the Power BI URL. But they can't see why one is slow, one is fast. So they've got this report, and this is great. The performance is there. They've got all the data they want. But there's a problem. They want to change it. No one's ever happy with data. They want more data. So with this, you can come in and go to your report view, and you can add more measures. You can add a measure there quite happily. But you can't add columns. You can't add extra data. So let's say you've got some more data in a spreadsheet and you want to bring that in as well to enhance it with this existing data. You cannot do that in a live connection model. But there's a way around that with this is the new DQOAA PBIDS model. You say it enough, it flies off the tongue. So if I come to this model here and I try and import data, so let's try and bring some more data into this. It's going to say no. A direct query connection is required. And you need to add a local model. There's also a button called Make Changes to this model, which does the same thing. Sometimes you'll get a tooltip down here that says the same thing as well. All this does is convert this data set from live connection into direct query. What happens if you do that? I will click this button instead. That's going to go off and ask me a couple of questions about which tables I want to convert. He says, hopefully. There we go, everything. So what difference does this make to writing a report? It looks the same. We go, when it finishes, we go to the visuals, has the same performance, same data. Once it warms up, oh, I've got a date filter on, time filter on. Let's get rid of that. And now it's nice and fast again. Nothing's really changed. Fundamentally, behind the scenes, a lot has changed. It's cloned the structure of the live connection underlying data sets, cloned it internal to this data set, but with no data. It acts as a table-by-table pass-through to the underlying data. Was there a question? No. But what this does now mean is that we can bring more data in. So let's say I'm in the sales department, and I can say, okay, well, I've got our web traffic, but I want to see the correlation between that and our sales. So I need to bring in our sales data as well. We can now pull in from a database and get old AdventureWorks. Let's look at our Fact Internet sales. Bring it in, and I want to import this data. It tells you about a potential security risk. All that is when you get these different islands of data, one in DQ, one in import, potentially coming from different data sources, it has to sometimes, when you filter one table, it has to then understand and filter the things you've asked for, send that text down to the other data source, building its own DAX calculation as essentially a subtable, so it can send some data values between these different data sources embedded within a DAX query. That's the only reason it gives you that. If you own all the data sources, there is no security issue. So here, Fact Internet Sales has no link to time, has no link to web page, but it does have a link to date. So let's get the order date key, map it to dim date, and we've now got a cross-island join between two different sets of data. We've got our direct query over analysis services, and we've got our imported data. So what we can now do is let's get rid of our average, we're finished with that, and instead overlay our internet sales amount. And now you've got two completely different data sources, one coming from another data set and one coming from a completely separate database, overlaying together, sharing conformed dimensions, the date dimension, or the product dimension, or customer, whatever it is. And then you can use this to say, well, okay, someone or a department can bring their own data in and overlay it on top of existing centralized Power BI dataset logic to stand on the shoulders of those other datasets, not reinvent the wheel all the time. Now, this functionality is still in preview, but it is incredibly powerful if you think about how this can help reduce the logic in your datasets around your business. So, before we finish that one, so the pros and cons of going back to live connection. Very fast report creation. You haven't got to worry about Power Query and DAX and everything else. It goes back to this old single version of the truth, the BI mantra for decades of trying to reuse logic. We moved away from centralized cubes into this massive Power BI datasets. We're now starting to get back to that centralization again, whilst retaining the power to customize that we've never had before. You don't duplicate logic, but it's a slower release process. Let's say that user in sales wants to change the website functionality. They have to come back to the centralized team to make that change. And it was rigid functionality. But when we start bringing our DQ model, let's go to that one, you get that ability to remove that rigidness, and you can start to expand and enhance your data to allow rapid changes. People can change their own stuff and enhance further without having to wait for you centrally to do it. So this is your typical direct query over analysis services and Power BI model, where you've got multiple islands of data, and they're joined by conformed dimensions. Maybe it's date, maybe it's customer. Question on screen, how will the refresh of the composite report work on the Power BI service? Does it need to configure the refresh of the import part of the model? Absolutely, because the import is the only thing that's being refreshed. The direct query part is just constantly live. So absolutely, it is only the import mode that does need refreshing. Keep the questions coming, by the way, more than happy to answer them. So here we've got three different islands. We've got a direct query model over a cube. We've got another direct query model over a Power BI dataset. We've joined those together. And we've got another import from Excel. You can combine that to whatever you want to be. However, that's not the only way you can use this. Who here likes Power BI dashboards? No hands, because they're rubbish. Why are they rubbish? Because they're static. You can't do anything with them. You click on them, you can't filter them unless you go to the underlying report. But what about this kind of model, where you've got two completely different data sets, and then you bring information in from both of those data sets and combine them into one Power BI report, acting as your dashboard? Then you can interact with them quite happily. They don't need to have a link. So you can bring visuals and data from lots and lots of different data sets into your own interactive, customizable, proper dashboard, rather than the Power BI dashboards. Question on screen. Can I add filters over several islands and can I have multiple relationships between two islands? Great questions. First of all, the second question, no, you cannot have two relationships between two. Oh, sorry. You can't have two relationships between the same table in the islands. You can have two relationships between different tables. I've never tried it, though. It's a good question. I will try and make sure. My understanding is that, yes, you can have different tables linked. So, for example, a date dimension and a customer dimension. You need to decide which is going to be the primary. What you don't want is to have two customer dimensions in your model. So decide that your underlying DQ model is going to be your primary, and then if you have a corresponding customer dimension in your import mode, then you want to hide it and just act as a filter coming through. One thing I need to point out is the performance of this is pretty good, only if you manage the links between the islands very, very carefully. Oh, actually, sorry, another question. Can you add filters over several islands? Yes, you can. Add filters to whatever you want. And if there's a link between them, it will propagate through. There's one scenario about that, which we'll get onto later, which is row-level security, which is a bit of a problem. I'll come onto that in a minute. So these cross-island joins, they have to be low cardinality. You do not want 1 million rows in that join table. You want to have 100 rows or 1,000 rows. It's okay doing it on dim date. Don't do it if you've got a million customers or things like that. You don't want to do it on order number, for example, because it has to take, if you filter one island, it has to figure out, so if you filter this table here, that then filters this, maybe that's a fact table of orders. That limits it to 100 million orders. It's going to have to build a DAX query that has 100 million values in a sub-DAX query to pass over to that island to filter that data set. You've got to be very, very careful about managing that. So if you get slow performance, that is almost certainly why. Right, so we've covered that one. So this gives you all of the benefits of live connection, the reuse of logic, but it opens up that flexibility to enhance further and to customize and to move forward. Do be careful, it is in preview, so therefore it's not supported. Yes? Okay, so question about row-level security, I will get onto that in a minute, because it is an important point. Sometimes you can find some unreliability in it. It's actually a lot better now than it was a few months ago, but just bear it in mind that you may want to be careful about using this too much until it goes into full GA production. Right, so things to know about. As I mentioned, it's currently in preview, so use that advice carefully. It does not need premium. A really cool feature that's available to pro users. Who'd have thought it? It works with any data, any workspaces, regardless. I mentioned the high cardinality cross-island joins. Do be careful of that. It is a gotcha, and it can limit the functionality of this, especially if end users are doing it who don't understand the difference between 100 rows and 1 million rows. You're allowed a chain of up to 3 data sets. So we've got a chain of 2, we showed earlier. I could add another one on top of that to get a third level in the chain. There's no plans to increase that further yet. Will that happen? I don't know. I personally hope it won't. I think that will create a management nightmare. So I think 3 is about right. Row-level security, back to your question. It is supported, but not cross-island. So within a single island, row-level security is honored. Now, if you've got row-level security on a region for sales or something, that will absolutely be honored in that island and filter all the sales to just that region correctly. Let's say you join to another island, maybe forecast information, based on region. The filter will propagate through, so it'll look like it works. But you've got the all function that overrides it to say, ignore that filter, show me everything. So yes, it may look like it works in some cases, but it doesn't. It's purely a filter, not row-level security, so it is not enforced. So do be careful with that. Permissions are required on the whole chain. So you do need, if you've got 3 data sets and you want to build a report on the M1, you do need permissions to all 3 to be able to do that. Because it's in preview, there are a few gotchas at the moment and limitations, which I'll give you a link to in a minute. It does now work on Azure Analysis Services and on-prem analysis services tabular if you have 2022 with a local gateway. It doesn't work on any versions previously to that. There is quite a long list of considerations and limitations. That is the link. I will post this slide deck somewhere and you'll be able to get that. But just search for DQ over Power BI datasets and you'll find it. Right, so the next thing we'll look at, question there. What are the chances of it becoming a premium-only feature? Good question. Usually when Microsoft say it's going to be Pro, it will stay as Pro. I think it would be very unlikely for it to go to premium. You'll need to go and chat to Casper, Adam, Patrick, or Christian to find out the details. They know, obviously, more than I do. So we've got our imported data, our sales data. Another scenario is, well, we need to import it, but actually we don't want to import it just overnight. I'll leave questions to the end if that's all right now, because I'm running a bit short on time. So we've got an imported data set, and it's fine being imported. Overnight, at midnight, it's fine, and it gets everything going. But we now want to see live data today. So we saw in the original composite model where you have two different tables, one direct query, one import. Well, we can do something quite funky with partitioning now. If we create an incremental refresh to partition this table and define our data, we only have to process yesterday's partition or last week's partition or this month's partition. But now there's an option for hybrid tables where you can say today's partition is direct query. So when you query that table, it will get everything it needs from the imported data really fast. And if you're asking for today's data, it will also query direct query, grab the data, combine it together, and give you a single answer. So you can now get live, up-to-date, real-time reports and minimize the impact and hit on your source system. So remember earlier when I said never, ever use direct query as a standard approach? That's because of this. If you're using direct query, why would you do that and not partition it and limit the direct query part to just today? So when you do that, it basically creates all these partitions. It manages them all for you. It's all handled automatically. Anyone that knows the pain of managing analysis services partitions, this is going to save you a world of pain. And the last one you see is our direct query partition, and that updates live without having to do any refreshes. So how does that work? Let's quickly jump back to our, this is our model that we created, the composite one with our fact internet sales. So let's say we want to make this fact internet sales a incremental refresh and hybrid. If we go to Power Query, then the first thing we need to do is to add some parameters to this. Now, these are very explicit as to the spelling, the data types, everything. So we need to have a range start parameter. Now, that has to be date time. I don't care if you only want date, it needs to be date time. And give it a random default value. And another one for range end. And exactly the same, it has to be date time. And we're going to give it a random default. The random default is going to be what Power Query and Power BI Desktop uses to show you a preview. When we deploy it to PowerBI.com, it will use these to create automatically all these partitions. Let's go back to our fact internet sales. So we want to partition this based on order date. We have an order date key here. You cannot use that because that's an integer, not a date. Luckily, we have an order date column, and we can then filter this with a between. And we're going to say, let's keep the rows where we are on or after the range start parameter and before the range end parameter. Note I changed this from before or equal to. If you leave it as that, dates that are on the edge will end up in both partitions. You'll end up with duplicated data. So one has to be equal to, the other one cannot be equal to. Do make sure you change that. Now we've done that, we need to go back to our model. We're going to go on to our incremental refresh. Now this is a premium only feature, so obviously it doesn't work in Power BI Pro. Turn it on, We want to keep, I don't know, 3 years worth of data. We want to do incremental refresh starting 3 days. And that's then going to give us archive data between 3 years and 3 days, and then incremental refresh for the last 3 days. Now we can also detect data changes. If you've got a date column that can actually be used to detect what data has been changed, you can use that. You can limit it to only go up to midnight, so you don't get partial days. And this is the premium only feature. Sorry, partitioning is available and everything. This is premium only. This is where it will automatically create you this real-time partition for today's date. And if we do that, that's it. All we've got to do is publish this, and when you publish it, Power BI will create all the partitions that it needs for you for that data, and it will manage merging them and manage everything about it. When you ask to refresh the data sets, it will decide which partitions it needs to refresh. Right. So, let's put all this together. We started out with our original data set where we had these 2 different tables, import and DQ, to get our composite model. We then layered another data set over the top of that in originally live connection, but then changed it to DQ so we can then import our own data to enhance it further. With all of this, it gives us the ability to find our own line on this eternal battle between centralization and governance and distribution, flexibility, and power to the people. You can choose where you want to be on that line now. Gone are the days where it was one or the other. And that really helps your whole governance and manageability of your estate. We like to promote a 3-tier architecture with who can do what and workspaces in an environment. Start out with your centralized BI team, the Power BI teams that really understand what they're doing. These are people that have got access to the data warehouse, the Delta Lake, whatever it may be, to build your certified, trusted core data sets. These are the ones that are going to be the single point of truth for the rest of your organization. And then departments, teams, or projects can then build their own report over the top of it, reusing that logic, as can individuals. But then we can say, well, we can also then provide other sources of data for the departmental teams to be able to say, well, I want to take that data and use composite models to layer on top of it and enhance it. Whether you provide those directly to the data lakes or through data flows, or they've got their own data sources, doesn't matter. They can then have their own departmental data sets that are their version of the truth. Their users can then layer their own logic on top of it by bringing in their own Excel forecasts or whatever they want to do. And this is our 3-layer, the 3 chains of the composite model we talked about. Okay, so let's quickly run back over this. Import is always going to be your #1 default for small, basic, simple data sets. Hopefully you now know the pain barriers of direct query. Do not do that. If you want to do that, we've got these composite models which create for 2 tables, switching between them for aggregated data to give you the performance of import over very, very large data sets to cover most of your queries. We looked at live connection, where you can reuse data sets or reports and allow people to create their own reports. That gives you the centralization aspect of it, the reuse of logic. Then we looked at the new DQ model, which layers the customization and flexibility over the top of that centralization. And now we've got the incremental refresh and hybrid tables that give you the real-time data with good performance that you've never had before. Your problem is now which of these models do you use for any given project? And that's why I wanted to go through these different options, so you've got the building blocks to decide which is right for each scenario. And there is no single right answer. It's up to what is right for each individual particular data set or workspace. So I will now take a couple of questions on the screen. Please do leave feedback using that link. I really would appreciate your feedback. Got a question. It works on Azure Analysis Services and AS22. Does it also work on Power BI Premium datasets? Yes, it does. Absolutely. Any Power BI Premium datasets, composite models will work on. Can you change what tables fields you include in the model without removing from the whole table model? No, you can't. It is what it is. And that underlying data set that you're using in DQ you cannot change. You cannot change relationships. You cannot change the columns in there. It is what it is, and it is fixed. All you can do is add your own stuff to it to enhance it. Good question, though. Question?
With the aggregate tables
Yeah.
being import, but the rest of it being also having the direct query, would there ever be a time when it chooses to use the aggregated table and gets an out-of-date value back, but actually adding in the time slice against?
That's a great question. So when you've got the composite model of one table's import, one table's direct query, you're going to get out-of-date data whether out of sync, because DQ is going to contain today's data, whereas the import isn't. Absolutely. So when you build your direct query table, you need to filter that to only midnight last night, or whatever your dataset refresh is. But yes, you need to worry about that. That's a very, very good point. We are now out of time, so I do have to stop so the next speaker can come on, but I will hover around here for any more questions if you want to come up to the front, or I will be over at the Power BI Sentinel stand if you want to come and talk to me over there. Thank you very much for coming to this session. Much appreciated.